Hello everyone, Jain to all. In this video lecture, I am going to discuss about the basic concept of theory of automata. In this, we have to discuss finite state machine, that is also called state machine or finite machine. This is classified into two parts: deterministic finite automata and non-deterministic finite automata. After that, we have to discuss about acceptance of string by finite automata. Firstly, we want to discuss what is meant by a finite automata. Finite automata, which we discussed in previously topic, finite means the state are, the string are, the input symbols are must be finite. Here we have to take in finite automata or finite automata are finite state machine. These are the name of the topic which we have to discuss here. Finite means here we have to call the number of state must be finite. The number of state must be finite. This is the abstract model of digital computer, and this is called automata, which discussed in previous slides or previous recording. Automata is the abstract model of digital computer. So we have to show here a digital form of automata. There are four components in automata. The first one is input tape, second one is control input, and control input connected with storage bidirectional connection. Why it is bidirectional? Everyone know. Bidirectional means we have to give information to the storage, and after performing some operation, we take revert back in control unit. Control unit generate the output. That this is the hardware diagram of given automata. This is the input tape. Input tape is divided into equal size of block called cell, and each cell contain a single symbol. This is cell, and the cell size is equal. Every cell is uniform and equal size, and each symbol is contain a single symbol. Each cell is contain a single symbol. After taking input, finite control take decision. Finite control having full authority to take decision about to process the given input file or input string. Input file, nothing more, that is the input alphabet. Here we have to write A, B, C like this. If you have A, B, C, D alphabets, so we have to write in input file. Input file process by control unit, and control unit push the data inside the storage, and this is the form of stack, where we have to process the given inputs in the form of stack, where we have to push or pop the given information, or we have to perform a mathematical or logical operation inside the stack. After performing the operation, we take data revert back to the control unit. After taking the back data, control unit generate output which have our desired result, which shown in the previous slides. The first one is input, control unit, storage, and output. As we discussed, input means the input file. Input file is divided into equal size of block called cell, and each cell contain a single symbol. The next one is the control unit. Control unit is a system which controls all type of activities, which may be initial state, next state, and final state, or it is a transition function. That means a finite control having following components: internal states and transition function. Internal states having initial state, next state, and final state, and transition function which take inputs from the keyboard and generate next state for the given input function. It is written like this in form delta. Delta state Q naught, input A, the next state is Q naught dash or Q naught. This is the form of transition function. Now the next one is storage. Storage means where data is stored inside the main memory, and after that this is the output. What type of output is generated by the given machine? Now, this is the classification of finite automata. Finite automata is divided into two parts: deterministic finite automata, that is DFA, and next one is non-deterministic finite automata, that is called NDFA. Deterministic means if the next state is unique, then the machine is or automata is called deterministic finite automata. And non-deterministic means if the machine having goes number of state after taking the one input and present state, then that machine is called NDFA. NDFA means number of moves, that means number of next state. But in case of DFA, there are one and only one move. Here we have to write the definition of deterministic and non-deterministic finite automata. A deterministic finite automata is one in which each move is uniquely determined by the current configuration. That means if the unique move, that means unique next state, then the automata is called deterministic automata. Here the basic definition, or you can say the technical definition or tuple definition of deterministic finite automata. This is the 5 tuple. A deterministic finite automata is a 5 tuple: Q, sigma, delta, Q naught, and F. This is the basic definition of deterministic finite automata. That means Q is the set of states in which all state, capital Q is the set of state, that means it contain initial state, or it may contain final state, or it may contain internal states. That's set of all states. Sigma is the set of input symbol, which is discussed in previous videos. Sigma is the set of input symbol, and that should be also finite. State is also finite, and sigma must be also finite. Here the delta is the transition function defined as Q cross sigma implies Q. Q naught is the initial state where we have to start the machine, or from which point we have to start processing is decided by Q naught, and Q naught is the subset of capital Q, is a initial state, starting state of a machine. Here F is the subset of capital Q. This is the set of final state, and it is written like this. It is written like this: delta Q naught input A, next state is small q. This is the initial state Q naught. This is the input symbol A, and this is the next state Q. After taking the input A, we have to move on next state Q. This is shown in the given transition function. Now, this is the some properties of the transition function. Throughout the automata, we have used different types of representation. From those, transition function is 1. We have number of representation. We have represent in the form of graph, or we have to represent in the form of table, or we have to represent in the form of transition function. Here we have to discuss about in the form of transition function. Here some basic properties of transition function. If we take input as a null at the initial state Q, we have to move on next state Q. There is no change in the state. Here I state Q, the input string is AW. We have to move on the next state delta QA. This is the unit production. We have to process a single one by one. Here AW is the sequence of symbol. First we have to process A, after that we have to process W, or we have to process W, after that we have to process A. This is the sequence of symbol which is processed by the given machine. This is a representation of DFA, which is telling a previous slide. Transition function, transition table, and graph. This is the 3 method which is used to represent a transition system, a transition table, a transition graph, which is 3 method which is used to represent a machine. Any types of machine, which may be deterministic finite automata, or which may be non-deterministic finite automata, or which may be Turing machine, or which may be PDA. Such all type, or these all type of machine is represented by three-way, and the three-way is transition function, transition table, or transition graph. Now, the next point is transition function. We saw what is mean by transition function. It is written like a form of delta. This is a transition function of a machine, which machine may be any types, which process any type of language, but that machine is written in the form of transition function. Here the state Q0, taken input A, the next state is Q0. Here state Q0, input 0, the next state is Q2. Q2, input 1, the next state is Q1. Q2, input 0, the next state is Q2. Q1, input 1, the next state is Q1. Q1, input 0, the next state is Q1. This is the transition function which may be represent a machine. And that machine is represented in the form of transition function. There is no need to, we have to write in the form of, only in the form of transition function. No, we have to write in the form of transition graph. We have to write in the form of transition table. But here we have to take a topic, the representation. So we want to represent how this machine is represented in the form of the transition function. This is the transition table of same machine. This machine is also represented in the form of transition function. Now, this given transition diagram can be represented in the form of transition table. This is the machine which is represented in the form of graph. We want to represent this machine in the form of transition table. Here we have to make a format of the table. This is the present state, this one is the next state, and this is the next state for this one for next state for input 0, and this is the next state for input 1. Here we have to mark some state that is called Q0, Q1, Q2. This is the Q0, Q1, Q2. Here we have to mark an entering arrow at state Q1 that show the initial state. The next state is Q0, Q1, Q2. Here Q2, Q1 and Q1. This is the next state for input 1, and this is the next state for input 0. Here Q1 is the initial state, but one thing is that we have to mark final state also. In the diagram, Q1 is final state and Q0 is the initial state. So we have to remove this entering arrow from here, and we have to mark Q0 entering arrow for initial, and we have make a circle for final state. That this convention used in case of table. We have to mark entering arrow for initial state and a circle for final state. Here Q1 is the final state, so we have to mark circle or Q1 for final state, and Q0 contain entering arrow that show the initial state, so we have to mark an entering arrow at Q0 for initial state. This is a next point which discuss what is mean by acceptance. This is the first application of finite automata. We have to design the finite automata. How we have to design finite automata, this is discussed later on. But here we show how the finite automata means how a machine accepted the given language, or how we have to process the given string by the given automata. Here some basic definition which is given to show how we have to say that the string is accepted or not. Here we have taken acceptance by a finite automata M. This is the finite automata. So we have to take a definition like previous finite automata Q sigma delta Q naught F. If delta Q naught A equal to Q for some Q belongs to F, a finite state is also called accepting state. That means after processing the whole string, if we reach a state Q and Q belongs to final state, then we can say the string to be accepted, otherwise rejected. This is a numerical example, and this is a machine. Here state Q0, Q1 and Q2. We have marked Q0 as an initial state and Q1 as a final state. Now, the question is that this machine is given and we have to take in some string 01, 00, 101, 0111, 1101, 100, 1100. This 7 string is accepted by the given machine or not. So, we have to check one by one. First, we have to consider the string 01. We have start with initial state Q0, comma, the string is 01, bracket close, here we have to apply delta. Now, state Q0, input 0. State Q0, input 0, the next state is Q0, so that here we have to write equal to delta Q0, comma 1. After taking input as 0, we have to left the 0 and write the string after 0. We have to 1 only, so that we have to write here Q0, comma 1. Now, state Q0, input 1. State Q0, input 1. The next state is Q1. Here we have to write delta Q1, comma null. Now, state Q1, input null. There is no change. We have to write here Q1. Now we have to check each Q1 belongs to final state S. Q1 belongs to final state, hence the string 01 is accepted. This is the final answer of this questions. Now, by same way, we have to check 00, we have to check 101, we have to check 0111. These string is accepted by the given automata or not. Do practice of this question. I am coming on the next question. In previous, this is the solution of that question which we have to mark here, 00, 1100. Now, this is a different question. In the previous question, we have given a diagram and set of string to check the given string is accepted by the given finite state machine or not. Here, we have the given table and we want to check this machine is accept this language or not. As we know, the machine is represented in any way, which may be a transition function, which may be in transition table, or which may be in transition graph. In previous question, the machine is given in the form of transition graph, but here the machine is given in the form of transition table. Now, processing this string, we have to write like previous way. We take initial state Q0, the sequence of input string 110001. We have to write all the string with same sequence 110001. Now, we have to take state Q0, input 1. State Q0, input 1. The next state is Q1. Here we have to write Q1 and 1 is processed. So, we have left 1. We have to write the remaining string 10001. Now, state Q1, input 1. State Q1, input 1. The next state is Q0. Here we have to write Q0 and after string which left after taking input 1, we have to write here. Processing in the same way, in the last state, we have to check the last state. And the last state is Q3. And now, check Q3 is the final state. The answer is no. Initial state is Q0 and also the final state is also the Q0. Q3 is not a final state, hence this string is not accepted. If Q3 is a final state, then this string may be accepted. The next point is, which is discussed in the starting, finite automata is divided into two parts, deterministic finite automata and non-deterministic finite automata. The whole discussion which is discussed in previously are going through the deterministic finite automata. We want to correlate deterministic and non-deterministic. In case of deterministic, we say there are single move then the machine is called a deterministic. If multiple move, then the machine is called non-deterministic finite automata. This is the case of non-deterministic finite automata. It may be possible in a state Q0, we take input 0, move on state Q1, or same input 0, we have to move on state Q2. Such type of machine is called non-deterministic finite automata. This is the basic difference between deterministic and non-deterministic. In case of deterministic, one and only one move. But in case of non-deterministic, it may be multiple move. Now, we comes on definition. A non-deterministic finite automata may have several possible moves. We have to take same machine M equal to Q, sigma, delta, Q0 and F. This is a machine which is so the property as NDFA when we have to write in the form of symbolic. Here same meanings. Q is the non-empty finite set of internal states. It may be initial, it may be set of final, or it may be some other states may be possible, where sigma is the set of input symbol, which same as previous, input symbols also the set of finite symbols. We never take infinite set, we always take a finite sequence of input symbol. Delta is the transition function, which is discussed in previous slides. This delta is of the form delta Q0 input A, the next state is Q1 dash comma like this. We have to write like this. This is called present state, this is called present input, and this is called the next state. After taking the input A on state Q0, we have to move on state Q dash. This is the basic concepts of delta. Now, the next part is Q0. As we discussed, Q0 means initial state, where we have to start our machine. It's called initial state, and the initial state must be a single state. As we know, we have to start a single point, so that initial state must be a single, but final state may be multiple, so that we have tell F is the subset of capital Q. It may be possible that multiple state final, but initial state must be a single. The starting point is single, but terminating point may be more than one. This is the combined form of this given machine. Now, how we have to represent NDFA, or how we have to represent DFA? As we know, DFA is represented by three ways: transition function, transition table, and transition graph. In same way, we have to represent NDFA. NDFA is also represented with transition function, transition table, or transition diagram. We know same representation. Any machine can be represented by a transition function, transition table, or transition graph. There is no difference between representation, so that we have to not consider that representation here. The representation which discussed in DFA, we also used in this point. This is the representation of DFA, but this same representation we have to use in case of NDFA. Function, table, and graph. There is no change, but change is that multiple move. In case of DFA, single move, that means single next state, but in case of NDFA, there are more than one move may be possible. That is the main difference between DFA and NDFA. Otherwise, both machine having same functionality, same task, they have processed the same given language. It may be possible, but the power in terms of DFA and NDFA is different, which may be vary from machine to machine. The next point is we discuss acceptance of string by a DFA. acceptance of string by a finite automata. That means it may be DFA or it may be NDFA. Same topic discussed in DFA, we also same topic discussed in NDFA. It may be possible कि given string is accepted by the given NDFA or not. It may be possible, and which is discussed same as in DFA. We have to check. We have to consider a machine and check the given string is accepted by the given DFA or not. We can same way explain the given language is accepted by the given NDFA or not. So these are the basic concepts which is related in DFA and NDFA. I summarize the whole topic. The finite automata, the main point is finite automata, which is the abstract model of digital computer, that is also called automata. This classified into two parts. The first one is DFA and second one is NDFA. DFA means unique move and NDFA means multiple moves. How the DFA is represented? There are three types: table, function and graph. And same NDFA is represented by three ways: table, graph and transition function. And the last topic is acceptance. We have to give a string and we check the given string is accepted by DFA or NDFA or not. This is the whole points which are discussed in this video. If any doubts, we can comment in comment box. Thank you. Thank you so much.